Section 1. Defining the danger. What is Kessler Syndrome? Space is vast, but the region around Earth is getting crowded. Satellites are essential for our modern world. They connect us, guide us, and help us understand our planet. But what happens when these technological marvels become hazards themselves? This is where Kessler Syndrome enters the picture. Imagine a chain reaction in orbit. Two objects collide, creating thousands of pieces of debris. These fragments then smash into other objects, creating even more debris. This cascade of collisions is the heart of Kessler Syndrome. It's a domino effect with potentially catastrophic consequences. The term Kessler Syndrome comes from Donald J. Kessler. He was a NASA scientist who first proposed this scenario in 1978. At the time, it seemed like a distant threat, but today, the risk is more real than ever. Section 2. A collision course, recent incidents, and growing risks. The International Space Station, ISS, is a symbol of human achievement. It's also on the front lines of the space debris problem. In November 2024 alone, the ISS had to maneuver to avoid debris. This was its 39th such maneuver since launch. The problem isn't just the big stuff we can track. Millions of smaller debris pieces are also zipping around our planet at high speeds. Even a tiny fragment can cause serious damage. In 2023, a NASA weather satellite narrowly avoided a collision with a defunct rocket stage. This near miss was a stark reminder of the dangers we face. Human actions are making the problem worse. In 2021, Russia destroyed one of its satellites in a controversial anti-satellite test. This irresponsible act created over 1,500 trackable pieces of debris, adding to the already congested environment. Section 3. The high cost of inaction, consequences of a space debris catastrophe. The consequences of Kessler Syndrome are far-reaching. Our reliance on space technology is immense. Satellites are critical for communication, navigation, and Earth observation. A cascade of collisions could cripple these systems, disrupting our daily lives in profound ways. Imagine a world without GPS, accurate weather forecasting, or reliable internet access. These are just some of the potential consequences of a space debris catastrophe. The economic fallout would be immense, potentially costing trillions of dollars and impacting industries globally. Beyond these immediate impacts, Kessler Syndrome could trap us on Earth. Space exploration and scientific research would become incredibly risky, if not impossible. The dream of humans venturing further into the cosmos could be dashed by our own technological debris. Section 4. Averting disaster, global efforts to clean up our act. The good news is that we are not powerless to stop this. Scientists and engineers are developing innovative solutions to address the space debris problem. The European Space Agency's ADO braking sail, for example, is designed to deorbit defunct satellites, reducing the risk of collisions. Other experimental methods, such as nets and robotic arms, are being tested for capturing debris. Advanced sensors are being developed to improve tracking and collision predictions. These technologies offer hope, but they are only part of the solution. International cooperation is crucial. The United Nations has taken steps to address space traffic management and debris mitigation. In September 2024, new guidelines were adopted to promote responsible behavior in space. However, enforcement remains a challenge, and more stringent measures may be necessary. The clock is ticking. Experts agree that the threat of Kessler Syndrome is real and growing. While opinions differ on whether it has already begun, the consensus is clear. We need urgent, coordinated global action to prevent a cosmic catastrophe. The future of space exploration, and perhaps even humanity itself, depends on it.